What is space weather? Well, essentially, space weather is a planet's interaction with its host star and the surrounding space environment. So let's get into what the star, our star, it's basically a giant fusion reactor that drives all of space weather. And because it's a big fusion reactor, we have energy output that comes in all kinds of forms. Because of all of this stuff, we have to stare at the sun in all different wavelengths, basically all different frequencies. It's kind of like looking at it from different frequencies of the ham bands. Every time we look at a different frequency, we're actually looking at a different temperature on the sun, and that translates to layers on the sun. This set of pictures, all the same moment in time. So that's not the only way we image space weather. We also look at coronagraphs. See that beautiful thing right there? That's a solar radiation storm. You think it only affects Earth, but it doesn't. It affects our space telescopes too. This is called the heliospheric imager, or HI. And so you're seeing all of this wispy stuff. These are coronal mass ejections. These are solar storms that are being blown off. Okay, so you'll see a solar flare along with a coronal mass ejection, boom, right there, and then you see this nice jet of plasma that comes out. Now, coronal mass ejections oftentimes happen at the same time as flares. Here's a perfect example. This is that one I showed you earlier. It's much more massive and much more slow, and it's got a loop shape because of the magnetic field. These are electrified charged particles that are forced to be constrained and to move around the magnetic field. So the magnetic field of the sun dominates how these things move and where they're allowed to go. By the time these structures reach Earth, they are about a quarter of the distance between the sun and the Earth. That's how big these things are. Okay, these structures are the ones that cause geomagnetic storms. Speaking of, let's talk about the Sun-Earth system. The near-Earth space environment is vast and complex, and the solar phenomena, they're just a first link in a very complex chain of events that lead to effects at the Earth. You know, most of you will recognize that I'm kind of talking about the ionosphere here. You've got the D region, E region, and F region. This is obviously an artistic diagram, but it's probably a little different than what you're used to. From the point of view of, you're not seeing smooth surfaces here. I purposely made these layers very warbly and to kind of give you a better idea of what's really happening. If you think almost like the surface of an ocean, you know, the ripples in the water, they're constantly changing, they're never the same, sometimes big, sometimes little. There are things like winds and waves and currents that are constantly moving. And this is the surface off of which your radio waves must propagate. It must bounce, reflect, and also all sorts of things can happen, as you can imagine. Anybody see, you know, you've ever been to look at the night sky and you ever see the stars twinkle? Like twinkle, twinkle, little star, and you wonder, that visual, you see how the light comes in and comes out and fades in and fades out? That is exactly, when you guys get signal fades, that's exactly what you're hearing. You're hearing twinkle, twinkle, little star. It's exactly the same thing. So I bet you'll never, now that you know that, I bet you'll never sing that song the same way again. So how does this affect the HF bands? Well, not just mentioning that ham radio was terrible, but how about this? Now I'm sure some of you know DRAP. Color means bad on this map. This is a solar flare. This up here at the high poles, these are due to the particle radiation storms. Maybe even more. Even in this week cycle we get them. Superstorms, how about this? This is March 6th through 15th, 1989. We had an X15 flare. The last slide was an X2. This is an X15. This was followed by a CME. So here is Enlil. Anybody who's seen my models or my videos knows this. The top panel's density, the bottom panel's velocity. You can see one solar storm coming out off to the west. Here's that second little guy. See him right there? So we have a potentially grazing blow from this solar storm. Amateur radio operators will be among the first to know on May 17th because you guys are the real space weather field reporters. Some parting thoughts. Amateur radio is affected by space weather every day. It's just like the weather in your own backyard. It's just a little further up. And there are a lot of misconceptions that exist. I mean, look at this to the left here. See this? I mean, you guys know now, this is the BBC, right? A solar flare races towards Earth. If it does, it already hit. 8 minutes, people. And please come visit me on Space Weather TV, on Ham Nation. Tweet me on Twitter. I am very responsive. And you can also email me at spaceweatherwoman@gmail.com.